Hello, I'm Carlos Rosas and this is Sierra's channel. We are going to continue with word problems this video. First, I want to make a correction. In the last video, I misread this number. I said it was 328 and it is 308. Okay, now we continue with this. You have 3 exercises with reference to this clock shown here in this drawing. So in the first exercise says at what time between 1 o'clock and 2 o'clock are the hour and minute hands of the clock opposite to each other. At what exercise 4b says at what time between 4 o'clock and 5 o'clock do the hour and minute hands of the clock coincide or meet. And 4c reads at what time between 6 o'clock and 7 o'clock are the hour and minute hands at a right angle. Okay, so here we have our clock. Okay, here it says at what time between 1 o'clock and 2 o'clock. So at 1 o'clock, the minute hand is pointing to the 12 mark, while the hour hand is pointing at the 1 mark, which means that at that instant, the hour hand makes an angle of pi 6 radians with respect to the minute hand. That is for the exercise 4a hour reference positions for the exercise. Now remember, I have 12 marks equally spaced, and the complete circle is 2 pi radians or 360 degrees, which means that each mark should be at 2 pi over 12 radians with respect to the previous mark, or 30 degrees. Okay, so with respect to the 12 mark, the 1 mark is at pi 6 radians, which is 30 degrees. The 2 mark is at pi thirds radians from the 12 mark, which is 60 degrees. The 3 mark is at pi halves radians, which is 90 degrees with respect to the 12 mark. The 4 mark is at 2 pi thirds radians, which is 120 degrees from the 12 mark. The 5 mark is at 5 pi sixths radians, or 150 degrees from the 12 mark. The 6 mark is at pi radians, or 180 degrees from the 12 mark. The 7 mark is at 7 pi sixths radians, or 210 degrees from the 12 mark. The 8 mark is at 4 pi thirds radians, or 240 degrees from the 12 mark. The 9 mark is 3 pi halves radians, or 207 degrees from the 12 mark, considering that the motion of both hands is in towards the right sense, that is in the dextral sense. The 10 mark is at 5 pi thirds radians, or 300 degrees with respect to the 12 mark. And the 11 mark is at 11 pi 6 degrees, that is at 11 pi 6 radians, or 330 degrees from the 12 mark. Remember, we are considering the motion of both hands in a dextral sense. That is, as is said, in the sense that the hands of the clock move. Okay, so the minute hand completes one revolution, or 2 pi radians, in 60 minutes. That means that it moves at an angular rate of 2 pi 60ths radians per minute, which is pi 30ths radians per minute, which is 6 degrees per minute. The hour hand moves or completes one revolution, or completes an angle of 360 degrees or 2 pi radians in 12 hours times 60 minutes, which is equal to 720 minutes. So that means that it does that at a rate of 2 pi over 720 radians per minute, which is pi 360ths radians per minute, which is equal to 0.5 degrees per minute. Okay, so the angle swept by the minute hand from its initial position during a time t, which is given in minutes, is equal to pi 30ths times t, pi over 30 times t. The angle swept by the hour hand, since it goes at a slower rate, from its initial position, that is when it's between 1 and 2 o'clock, which is starting at the when it points at the 1 mark, and when it's at between 4 and 5 o'clock, it means that it starts, its initial position will be when it points towards the 4 mark, and for the time between 6 and 7 o'clock, that is when it starts from pointing at the 6 mark. The angle swept from those, starting from those initial positions, will be given by the angle pi over 360 times t. Now remember that it starts at each of these initial given times, that is 1 o'clock, 4 o'clock, and 6 o'clock. It starts at an initial angle of pi 6 or 30 degrees from 1 o'clock, at 2 pi thirds or 120 degrees at 4 o'clock, and at pi or 100 pi radians or 120 degrees at 6 o'clock. That is our initial angle alpha. Okay, so the angle swept by the minute hand will be equal to the angle swept by the hour hand plus the initial angle plus the angle which is determined as initial information, which should be the angle at which each of the difference angle between the two hands when at the time that is to be specified by the problem. For example, here at the 4a, we're talking about the time at which the hour and minute hands are opposite to each other. That means that that difference angle between the hour and minute hands should be, if they are opposite to each other, in the case at 1 and 2, between 1 and 2 o'clock, it means that if the hour hand is between the 1 and 2 marks. The minute hand should be between the 7 mark and the 8 mark, which means that the difference angle between both hands should be of pi radians or 180 degrees. That is what means by saying that they are opposite to each other. So that angle, that difference angle, is pi radians. Now remember that here we are working with radians. Now we could have done the same thing with degrees, but I'm going to leave that for you to do as an exercise. So we have the angle struck by the minute hand equals the angle struck by the hour hand plus the initial difference angle between both hands plus the final difference angle between both hands. So that means that pi over 30 times t equals pi over 360 times t plus pi 6 plus pi, which means that 1 over 30 times t equals 1 over 360 times t plus, this is 1/6 plus 1, which is 7/6. We multiply everything by 360, and we have 360 over 30 is 12, so we have 12t equals 360 over 360 equals 1, so 12t equals t, plus 360 over 6 is 60 times 7 is 420. So 12t equals t plus 420, which means that 12t minus t, which is 11t equals 420, which means that t equals 420 over 11, which gives me 38.18182 minutes. So that means that at t equals 1 o'clock plus 38 minutes, 10 seconds, and 909 milliseconds, the minute hand is opposite the hour hand. So we will continue with the exercise 4b in the next video.